We are continuing the next talk with memory forensics and detection of unknown malware. And we are looking forward to the talk. Thank you.
Thank you. Good evening, everybody. I know it's late in the day, and I'll try my best to keep you guys engaged, and hopefully you will have something to take away home. I know we are coming to the end of the conference, so yeah, let's get started. Hi, everybody. My name is Fahad Ehsan. I'm a cybersecurity researcher, a so-called cybersecurity researcher. I'm still learning the craft, and in my day job, I work with the large European bank UBS. My areas of interest are vulnerability management, malware reverse engineering, and obviously memory forensics. I used to be a developer in my previous jobs. I have been in different roles within security, like SOC, security, architecture, design, governance. So I have some experience in those areas. Today I'm going to be talking about how to detect unknown malware using memory forensics and security analytics. When I was, and what I'm going to show you guys today is based on my personal research, and I'll share what we can do today. I know a lot of people know about memory forensics. It's a hot topic nowadays. So we need to. I'll share with you how we can get started with it easily, and what are the tools you can use, and let's get started with this. So before I go any further, can anybody tell me what this is? I know it's a screen capture from Google Maps, but what do you guys see over here? Can somebody tell me what this is? Okay, basically this is the place, or it's highlighting a place. It's called BrainNet. It's a company based in Pakistan, in Lahore, and it is alleged that the first mass-affecting malware was created over here. So basically, BrainNet is a company which provides ISP services and telephony services in Pakistan. It is still in business today. In early 1980s, it was starting up with its businesses, and so it is alleged that the first malware was created here. What was the malware? It actually changed something in the boot sector of a 5-inch floppy drive, and what's interesting is that this malware was not created to do anything harmful, but to spread a message. The message was basically this company was also doing some software for medical companies or resellers. So a lot of piracy, as you know, piracy is a big problem globally, not only in Pakistan. So they were actually trying to promote their message. So they changed the boot master record of the floppy drive. What's more interesting is that the ground you see opposite to it, I used to go there very frequently in my when I was young, and I had no idea that the malware was created there. From outside, this building looks fairly nondescript. Like you cannot see that it's actually they're running a business, so it's like a garage, but it's like a normal looking house, and you cannot see. So I used to frequent this ground with my family, and I have loads of memories there. So I was telling you that the master boot record of the file. So whenever somebody plugged into the computer, it changed the master boot record, and it added this signature there. Welcome to the dungeon, 1986, Basit and Amjad. These are two brothers who were actually running the firm. And as it says, beware of this virus, contact us for vaccination. So basically they're trying to promote that, do not, so they were trying to raise awareness against piracy. So I find it quite interesting. You can read more about this at the F-Secure website on this. So this is where I think the whole thing about malware got started. And if we fast forward to 2014, this is where we are. So Malware was one of the malwares which was detected recently uh, by RSA. There is a report by RSA on this Malware. So Boleto is a which takes the name Malware from. So Boleto is a sort of a transaction-based system which is very popular in Brazil. Basically, what it does is that the payee to whom the payment needs to go to, they raise a request online, and it generates some sort of a transaction receipt, and that is sent to the payer. And the details are pre-filled. Some of the details are pre-filled. Other details the payer sends. So as you can imagine, this is an opportunity for the man in the middle attack. People who can intercept those kind of transactions, and they can write their own signatures, and the money gets transferred to their account. I will not go into further details into this, but the key, the bottom line here is that the techniques which have been used in these Boleto attack are fairly well known. So what I'm trying to understand is why do we have cases like this? We are talking about 2014, and we are still having these kind of, malware attacks. I won't even call them malware, but these are campaigns. You see the amount of money, 3.75 billion and still counting. And according to the report, this malware was first found in the wild in 2013, but nobody is sure how long it has been there, and it was only detected in 2014. So I'm just questioning why it took all the malware companies out there, or the antivirus companies, more than 1 year to detect, where a lot of people have lost good money. These are people like you and me, These are not like big corporations who are being targeted. These are normal people who are doing their daily work, daily transactions, and they are losing their money. And it is using the technique which is being used is man in the browser technique. All browsers were found to be susceptible to this because the hooks which were made were in the system Windows API calls, and that is where the malware intercepted, and the intruders added their signatures. So I'm just wondering what is happening and why we have this situation. But if I go slightly back in early 2010s, 2011 and 12, there was a lot of noise around a malware called Turla. So a lot of people, a lot of research companies like Symantec and Kaspersky, they came up with telling people that they know about a malware, but they don't know what exactly it is. It is involved in cyber espionage, and it originates from Russia. But beyond that, they were not willing to tell anything, or they didn't know. They don't have enough intelligence to say what this is. Fast forward 2014 again. I have this report from FireEye. Basically, they are talking about similar kind of attacks which were reported in 2012. So for 2 years or 3 years, nobody knew exactly what is happening. There were talks that a malware is out there by Russia, but not knowing exactly how to defend against that. So this has been going on for a while. So that is the message, that malwares which are not known to the public, or which stay stealthy for long periods of time, they have been in the wild, and there is not enough being done or to protect the public, or maybe the corporations or government agencies. And we see cases like this over and over again. If we look back at 2014, it has been a year of major incidents, majorly because of the hype which is created around all of these. For those who have been following 2013 as well, there have been large instances of zero-day vulnerabilities found in Java and Adobe and whatnot. But this has been the year where vulnerabilities or major incidents have really come to the show. Things like Heartbleed, Poodle, Bash, Shellshock, and not to forget the JP Morgan case, where we still have limited knowledge what exactly happened there. So these are not exactly unknown malware or zero-day malware, but these are sort of zero-day vulnerabilities which can be utilized by unknown malware. So this just goes to show that how much we don't know what is out there. So this sets the scene for my talk about unknown malware. and you know, that situation where we are. So today's agenda is, I'll briefly talk about unknown malware. I think I have talked enough about it, but I'll just wrap it up. And then something about memory forensics, IOCs, threat intelligence, security analytics. I know these are big fuzzy words. I'll try to explain to you guys what these are. And in the end, I will try to introduce to you guys some of the research work I've done and my proposed solution, how it would work in reality to detect malware, unknown malware, which we have just seen. What is unknown malware? Unknown malware is anything which is relevant to your environment and it remains undetected for a certain time period. So that means that every malware which gets out in the wild remains unknown for a while. That period can remain from few days to a few years, as we have seen. And that is truly what unknown malware is. Don't forget that unknown malware can be is always relevant to your environment. So if there is a targeted attack on you and you don't know anything about the malware, that is unknown malware for you. So any malware which is not detected by traditional modern security toolkits at any given time is considered unknown malware. The bottleneck is generally the time taken by the vendors to update the signatures and contents. We have seen it. The previous speaker set the scene for this, why antivirus does not work. So this just delves into that. Again, unknown malware can target specific environments. A good example is Stuxnet, which was a fairly elaborate malware targeted towards a centrifuging module designed by Siemens, running into in the Iranian centrifuging, plant. So you can see how targeted that is. As I said earlier, unknown malware generally targets zero-day vulnerabilities, as there is little protection against such vulnerabilities. So this is unknown malware for you. Common enterprise toolkits. If we look at the landscape of enterprise toolkits or even commonly used software and security software, you can see that there is a range of layers of protection, starting from the host-based to network-based. But what is common among all of these layers of toolkits is that they are all based on signature. Either they are based on signature, they are based on heuristics, or some policy. So the bottom line is that why there is so much unknown malware is because the tools which we are using are not geared towards detecting those kind of malware. So if a vendor has not published a signature for a given product, you are out of luck. You don't have any protection against that. You can do some mitigation controls and whatnot, but that means that you have to take an action. So the bottom line is that, again, all the toolkits which are out there, generally, they are based on fairly static signature-based signatures or some part heuristics, but they don't have a capability today to detect advanced malware. So in comes a new generation of tools, which is called on-host forensics, which allows a better capability. I won't say that it is foolproof, but it provides a better way of detecting malware. So some of the products which you might have heard about are Mandiant Redline, Carbon Black, Encased e-discovery. So these are tools which are doing automated forensics on the host, either periodically or on demand, and they allow you the capability to go further than a normal standard run-of-the-mill antivirus. And you're going to hear more about this in the future as well. So my focus on this new area which is developing. So if you take a step back, what is memory forensics? Memory forensics is basically I would say the art of analyzing memory to detect, pieces of information which are left by malware in the memory. Generally, memory forensics is done on a dump of a RAM. That means that an image of a RAM is taken. You need to have an image of the RAM taken before you can do memory forensics. So our memory dump is taken from a live system, and you as an analyst try to try to analyze the memory and try to find out what actually happened, what actually transpired in the memory, or where are the places where you can look for uh, 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 the artifacts left by the malware. So generally, it's used for incident response. Once the machine has been infected or it is showing some suspicious behavior, this technique is used for incident response. Uh, Again, the findings can be used for future investigation, and it can be used to build internal repository of known malware. So you're trying to spruce up your defenses by building up your repository of known malware. Even maybe in some cases the vendor has not provided you those signatures. So all the findings you have from memory forensics, you can put it in a central place. How memory forensics tools work? Basically, they do either periodic or the tools allow you the capability to do deep dive into memory artifacts or memory structures and allow you to extract information from there and then allow you the capability to do analysis, either do snapshots of the artifacts. For example, you can do a list of the processes which are found there or all the connections which were there in the memory at the time or which were found in the past. So you can do all of that kind of analysis. So this by hand memory analysis guide is from SANS. It goes like something like identify rogue processes. So these are step-by-step processes. So this just goes to show how, so basically what these tools do is automate many of these steps and help you do active memory forensics. Threat intelligence. What is threat intelligence? It's any source of information which provides you early warning about an emerging threat which is applicable to your environment. So this source of information can be either through FBI briefings or cybersecurity communities or your internal research, or it can be open forums like Facebook or Twitter, or closed source peer discussion. So these are the major sources of threat intelligence. There are obviously open source communities which provide you with the IOCs as well. For example, OpenIOC, Cybox. So these are standards which allow you to store and manage threat intelligence. So using memory forensics with security analytics. So we have learned today that what is memory forensics, what is threat intelligence. I'm just trying to put all of these together in the context of security analytics. What is security analytics? So security analytics, in my mind, is a strive towards single point of view of security. You're trying to put all the possible sources of information which provide you insight into security data, and you put into a single place so that you can do massive historical analysis or trend analysis or finding anomalies in your environment. So today, a full-scale security analytics solution does not exist. I have talked to, in my personal capacity, I have talked to a lot of vendors out there who provide analytics solution, but when it comes to security analytics, I have not seen any solution which is comprehensive. Right now, what we are seeing is that some of the features in SIEM are slowly and gradually being moved into security analytics solution. Like a lot of companies are trying to do packet capture with SIEM, and they're trying to sell it as security analytics. So there is a long way to go in getting to this state. But in essence, this is how I think a security analytics solution should work. So it should have a capability to be able to add extra data sources, which memory analysis data being one of them, and so the whole purpose is to detect malware or unknown malware. So I will not spend much time on this, but this is just talking about IOCs and signatures, how they are slightly different. IOCs are, how to say, slightly, they provide you early warnings, whereas signatures are specific to a vendor. So for example, if you're running a vendor, antivirus solution from a given vendor, signatures are tied to those, whereas IOCs are generally, they can be experimental information which is still emerging, or you don't know enough about that information. So those are called IOC, but both can be used for your purpose. But the limitation in both of them is that somebody needs to report to you. some human being or some system needs to report to you both of these sources. If you don't have a source for either of these, you will not be able to detect malware. And the key is that obviously you need something smarter than this. So if we talk about detecting known malware or based on signature or IOC, this is, if we talk about for the context of security analytics solution, this is how it would work. For example, you get memory analysis data from an existing source. You also have a IOC data coming in from a threat intelligence. Basically, we have a signature which is for Zeus, and it resides in the security analytics solution. So what you do is you compare the memory analysis data with the IOC, and that is essentially how antivirus works. So if you are to use a security analytics solution like an antivirus, which is sort of not on the system, this technique can be used for that. But again, this is for detecting known malware because it is based on IOCs, and we already know what Zeus looks like. But in order for us to detect unknown malware, we need to have a different methodology how to go about detecting unknown malware. What is that? So in my opinion, we need to have a better understanding of our environment. So in comes the concept of baselining. So I know we use this word baselining in other parts of security, for example, penetration testing, or we have a checklist. So we always talk about baselining. We need to baseline it. So in this case, when I say baseline, that means collect all the possible information about your environment and store it somewhere so that you can compare it. Whenever we need to find anomalies, we need to know what is the known state. So the known state is the baseline. So your baseline may change when, for example, if you build a new version of your build, your baseline would change. So you need a mechanism to be able to document all of the changes. So when I say baseline, that means everything and every single thing which is running on your machine, you need to have the capability to be able to document it, so that you can compare it later. So that means all software which is installed on your machines, all programs which are installed, all list of executables, DLLs, everything, single thing which is on your machine, which you should be able to store it in a meaningful way where you can compare it. So that would set the scene for detecting unknown malware. How it would work is fairly simple. Again, I'm leaving that the security analytics solution should be able to cater to to dealing with the baselining and comparing it against the newly found information. For example, the last known baseline, we already know what that is. We have a latest source of memory analysis data. Whenever there is an anomaly, that means that that is your starting point for doing further investigation. For example, you in your environment, you know that probably on a given PC, you only expect 100 processes to be found on your machine. Whenever a new process comes in, which is, that needs to be investigated further, or that could be something suspicious. That means that you also need to have control over your environment. You need to make sure that your users are not able to escalate their privileges and install extra software. So the baselining along with the security controls, that will set the scene for detecting anomalies. So how it would work is that you get a source of memory analysis data and you compare it against your last baseline, and there has to be some mechanism of reporting or raise alert once an anomaly is detected. So this is how you can go about detecting unknown malware. I know I've talked about a lot of detecting known malware, unknown malware, so I'm going to show you how you can go about doing it. So my solution, which is based on an existing toolkit, which is called Volatility, it's an open source, freely available tool which you can get started with for doing memory analysis. It has capability to analyze memory from Windows, Linux. It can also allow you to capture indicators of compromise by listing all the memory contents as text files or dumping files. It generally focuses on items like processes, connections, registry keys, whatever comes to your mind which resides in the memory, it will be able to list down, and you can use that information. So the solution, how the solution works is that step one, so imagine that I have an agent, some sort of an agent which is sitting on the host, and it is able to dump the memory in a secure hard drive. Again, that is transparent to the user. Bear in mind that this agent would be like any other enterprise agent, like SCCM or any other antivirus agent. So it would be transparent to the user. What the agent does, it dumps the memory to a secure location without impacting the user experience. The step two is that a job runs which initiates a volatility program, and it dumps down the list of processes, registry key, connections, drivers, whatever comes to your mind from the memory. It has the capability to dump it, and that information is collected and sent to a central server. Now we extrapolate this idea. So this process of listing out artifacts from the memory, it happens across all of your environment. Imagine hundreds of thousands of your machines sending you memory analysis data into a central place. That would allow you to do active analysis of your memory and trying to find anomalies in that. How you can do that? Let me just show you. Just a little bit about my lab and setup. I'm going to show you a demo which will show you some of the things which I highlighted just now. So I have a Windows XP client, 1 GB RAM. My security analytics solution is the Windows 7 server machine running a SQL server. It has some sample sets of IOCs already loaded. The server receives data from the clients in this way. So be it whatever the flavor of the OS, the client will send the data to a central server, and it processes it further. Let me just go to the demo. Okay, here what I'm doing is that I already have a memory sample which is infected by Zeus. So I know that this sample is infected by Zeus, and I'm running a batch file which you can consider can be running in a backend. So this can all be automated like an antivirus solution. So this will not impact the user experience in any way. So what it is doing is it is assuming that the machine is infected by Zeus, and some analysis is being done on the machine. So as you can see that I'm going to show you what it has dumped as a result of the analysis. So it is going through different sort of plugins which are already available in Volatility. What I have done is I have customized it to a large extent where I'm able to control the output, and the output is looking something like this. So it lists down all the This was not expected. Let me just go back. So basically what it has done is that it has listed all this is a certain kind of artifact. This is the system link, sysm link, sim links. These are links to files. So it has listed down all the links which it found in the memory and put and dumped it to a single file. So what is going to happen later is that all the files you see over here, they will be zipped up together automatically, and they will be sent to a central server. So now I'm switching to the central server. So once the server has processed the files, it will load all the data which we just received and load it into a table. So what that means is that all of the memory analysis data from your hundreds and thousands of machines are loaded into a single table. Obviously, this one is showing the PS scan. This is a common plugin which is used to list down all the. So what it is showing is the list of all the processes which are found in the memory. So it has processed them and loaded into the central database. So now what it is going to do, I'm simulating that if you are to detect a known running against a list of IOCs, so what I do is I run it against, again I'm simulating it as a query, but all of this data is stored in the tables. And I'm simulating that, you know, the system knows about these IOCs, and it is able to match the IOC against the memory dump data. And it says that it has detected Zeus. So this just gives you some understanding of what I mean by detecting known malware using IOCs. Now let's talk about detecting unknown malware. So now in this case, in the previous case, I had a list of IOCs, so that helped me to detect malware. In this case, I'm actually unzipping a malware, and I do not know anything about this malware. I will not be using any IOCs, but I will show you the technique which I've been talking about, the concept of baselining. This is where it shows its value. So what I've done is I've launched the executable, the malware, and I have infected the machine. I had already taken a snapshot, the previous snapshot. That was my baseline of this machine. And now I'm forcing another snapshot. Imagine that this runs every 30 minutes, so you don't have to do it manually. But I'm launching it now, so it will do the memory analysis on its own, and it will send this data to the backend server. So what I've actually done in the backend is I've customized this script. I've customized the volatility in a way that it is producing standard outputs, and then I have written some sort of a program which actually reads the output from the output and puts it into this database. So let me just stop here. What it is showing here is that, so I have two images of the same machine. The images, if I go a little further, so basically this shows that you can see the name of the node is node 1 in both cases. The time difference is about 20 minutes in between these two images. So what it is showing is that it has two images of the same machine at different times. That's all it is showing. And then obviously what the system should be able to do is compare the two images and trying to detect anomalies between the two. So what I do is we do comparison one by one. So what is the new list of process which was found? In this case, you can see without any IOCs or anything, I'm able to do a simple comparison against the last snapshot, and it is showing me that the differential is a new svcp.exe. This is the same malware which I launched, and the server, on the server, it is able to detect the malware without any IOCs. So this is just simple, basic. If you look at the query, it is not doing anything. It is just comparing the results from one snapshot to another, and it is able to find out an anomaly which is a cause for further investigation. Please take note of the PID. PID is 192 in this case. So if I do further analysis of the same, so I want to know more exactly what it is doing, what the malware is trying to do. So I can paint a very good picture with doing further analysis on the sockets. So if I do look at this one, so it is showing that there were two sockets which were found, two ports which were found, and those both are associated with PID 192. So ports 113 and 1320. So this is based on simple queries doing differentials. Again, all of this can be automated and put into a nice UI if you like. I do further analysis on that, and I try to find out if there were any new processes, services which were found. So this is the PS scan, process list. So this is the process list. So two new processes were found. Again, I do a connections list, compare in the connection if there were any new connections found. Again, you can see that this is the new connection which was launched by the PID 192. I do further analysis on going by the same theme, and I do try to find out where does that IP exist, what is the latitude, longitude. All of this information is freely available. So I just load it into my database, but I'm trying to compare from the IP. I know the IP of that, the destination IP. I take the destination IP and try to do some analysis on that, the start IP, the end IP, and it will tell me exactly where that IP is. Obviously, this is a older malware. Imagine if it is a newer malware, it would tell me exactly where the malware is originating from. So in this case, it is from US, and the latitude, longitude is there, the ports and all the IP and the information. So all of this good information can be had within few seconds. So the bottom line is that within 20 minutes, within a span of 20 minutes, you are able to detect something new, which you didn't know before. And in this case, you can respond to incidents well before any of your vendors are able to provide you with a signature. So that is going to start a starting point for further investigation. Sorry, I'm just going back to the place where it. Okay. Okay. So I've shown you how an open source tool can help you get started with detecting unknown malware. It's not very technical. You can get started with this if you have the right people or the right skill set, but it is not something which you need to buy a very expensive solution. So this is one of the benefits. So Volatility provides you with a cost-effective solution. Basically, it's free. You can customize it to what you like to do it. It provides I believe it provides a vital source of information which you cannot get from any other source today. As I said, it is flexible. The script can be changed to suit your environment and scale in the future. It can also be integrated, since it's open source, it can be integrated into any type of threat intelligence source out there. And it can help you detect unknown or known malware in that case. Obviously, with this kind of solution, there are always concerns. The major concern in this is the CPU power. I tried to do 1 GB RAM processing on a relatively powerful machine, and it still struggles. That just goes to show where we are today. But I believe that as technology improves or enhances, in the next 3 to 5 years, we will be in a good position to do active memory analysis of large memory sizes like 16 GB, 32 GB. But as I said, that this tool is flexible, and you can start with whatever you like or whatever makes sense. For example, you don't need to dump the whole memory. You can just start with very basic stuff like the executables, the process list, the connections. Even this information is very good, and you can match it with your network analysis tools. It is obviously based on open source tools with limited support. There are always data privacy concerns when you're doing memory forensics, because you can actually dump out the password hashes and whatnot. There are other pieces of information like IE history, which can be a cause of concern as well. So there are always, whenever it comes to forensics, you have to find a balance what suits your environment. So where do we go from here? Basically, what I have been able to show you is that with the open source tool, you can automate many of the steps which are recommended by SANS. What I've not been able to do is obviously dump suspicious processes and drivers. Basically, this requires extra engineering work, but this is possible. So what we learned today is that you don't need a fancy, a very expensive solution to get started with memory forensics. Obviously, there are paid solutions out there which are fairly expensive, in my opinion, and they also provide you with limited benefits of memory forensics. What is the big picture? As I said at the start of my talk, Memory forensics is a growing area. Uh, and security analytics even is more, you're going to hear more about it because I feel that it is at a very infancy stage. People are still playing around and trying to understand what it means for them, whether the organization is willing to spend money on it. One of the recent research papers by Gartner said that over 90% of our organization either don't have the resources or they're not even thinking about working towards security analytics. But my opinion is that if you are serious about detecting unknown malware and protecting your environment, you need to get started with security analytics because that is one of the ways you can protect yourself. Because if you continue relying on the vendors, the vendor products are good, but they only have a limited, they can only provide you with limited protection. And if you are really serious about your company's protection, you need to get your hands dirty and build up your resources and your research capabilities. In the end, I would like to give credit to Lenny Zelster. He's one of my mentors. Also, Jamie Levy, she's heavily involved in Volatility project. If you want to get started with memory forensics or malware reverse engineering or anything related to SOC activities, this is a very good resource. And finally, questions. I was a speaker at RSA conference last year. If you are interested, I'm also a trainer. I'm going to be a trainer at Black Hat 2015, talking about a similar topic, detecting advanced malware using volatility and R. So, yep, go ahead.
Thanks for the talk. We've got some
Yeah, in your example, you just take the memory baseline and you just add a process that somehow you know it's a bad process. In real life, I guess you have a memory baseline and the second snapshot that you are taking will be quite different from the first one. Most of the time will not be different because malware, but will be different just because of normal use.
Right.
So wouldn't you have a lot of false positives, and wouldn't that at the end make almost impossible to find really the instances of malware because they are hiding between a plethora of just normal behavior?
Right. Yes, you are absolutely right. So there is a large chance that you're going to be hit by false positives when you start. But as you do more research and you have built a list of whitelisting. Imagine, let's take a step back on this. Imagine 10, 15 years ago, IDS, right? IDS had similar challenges. It had a lot of noise. Look at IDS now. The vendors claim that they have a good hand of it. What this tool or this talk is supposed to give you is to get started with memory forensics. It does not give you a perfect solution, but at least it gives you a starting point to start thinking or identifying those anomalies, right? You mentioned false positive. I totally agree with you. It's going to be hard. But as I said, if you are serious about detecting unknown malware, that is the step you have to go through. And like we have seen, IDS is a good example for that, right? Everybody has gone through the same cycle. Yeah.
What do you see as the resource requirements, both in personnel and hardware, for running something like this? I ran some very quick numbers. If you said a snapshot every 30 minutes. If you say a 4 gig machine and 90 people, you're talking 200 megabytes a second coming in to your system, 720 gigabytes an hour. And you said modern machine struggles with a 1 gigabyte sample. So, but both in terms of the people to analyze all of this data and the resources for backing
as far
it.
as the analysis is concerned, it is I don't have any numbers for security analytics solution because it's a separate topic. But obviously, if you are to do a massive analysis, we are talking about a solution, some resources which are able to tackle probably terabytes of data on a daily basis. And as I said, that right now, this might not look feasible in today's circumstances, but we are talking about future, right? In the future, you can tame it to an extent, what pieces of information you want to extract. So you don't want to get crazy with dumping everything. So you again, according to your resources and the technical skills you have, you can tame it to a large extent. So, but again, as I said, that this introduces to you how you can get started with it. this is not a complete solution.
Where can I get your code?
Sorry?
Where can I get your code, right? You showed us some stuff that you basically, you added some value above and beyond volatility, right? You did your own analysis, you have your own database, right?
Yeah.
That's the core value of this talk, right? The fact that you created that,
Yep.
where do I get it?
I don't have it available online, but I can give it to you or whoever wants. I mean, if somebody wants, this is my email address. You can reach out to me, and I'm happy to give you the code.
Sure.
Or another option is you attend my course.
Right, well, so, you know, it's good that you said that you're willing to give the code, right? Because if you're not willing to give the code, then what did we get out of this besides, hey, you can use volatility? All the rest of it is just, you're just leeching off of what volatility has already done. So I think you probably want, if you're going to continue to give this talk, you want to make your code publicly available.
Yep, that's a good thought. Yeah. Yep. No, the intention was always there to share the code. But yeah, you're right, yeah.
Further question from me. I didn't see anybody. Don't you fear that malware will hide its tracks? We already seeing malware that infects the kernel or something. So you may not be able. You need a privileged process to access memory, and in the end, malware could hide, could protect from your evidence gathering. So in the end, you could do it on a virtual machine on this hypervisor level, but
you see, right now what happens if you look at how people do memory forensics today, right? They still use the similar tools. They still use volatility to dump the memory. So it is no different than what people are doing today. Again, as far as the limitation is concerned, obviously, if the malware has capability to detect, as soon as you launch a memory dump tool, it can try to hide itself. So that is obviously a concern, always going to be a concern. But I think for large parts, the malware which we see, I think it does not have that. There will be malware which has that, but you will still be able to capture a large amount of malware with this technique. Because there is nothing else which can help you. Even advanced tools like NCase, the malware can easily bypass those for forensics. Yeah.
You need to work on a different level.
Yeah, exactly. Okay. Yeah.
More questions? Then thanks a lot.
Yeah.
Thanks.